Hi, this is Saranya from St.Joseph College of Engineering, Department of Computer Science and Engineering. Today I am going to present topic on associative memory. This topic is basically under soft computing. In this topic now we will be seeing about the two problems. Before going into the problem, we will see what is the main concept of that particular thing. To associative memory. What is associative memory? Associative memory is nothing but a normal memory management system where we will store the information and where we will be retrieving the information. Basically, storing of information and retrieval of information will be happening in the database management system. The same kind of thing will be happening here also. But the difference between there and here is how we are going to retrieve the information. We will be retrieving the information based on the input that we are giving. Just consider we are giving some sort of input like x, y, z to one input system. Okay, the input system says x, y, z. Now we have to access this y. How we will be accessing it? Here what the main process is carrying out. Okay, the accessing of here will be happening based on the input that we are giving here, which means like the first input x will be saved and retrieved, and then y, and then z. So this kind of total formation will be happening in the associative memory. And coming to this associative memory, it is basically of two types. One is auto associative, another one is hetero associative. This auto associative is nothing but when we are giving the input, it is going to get the output just by making a pattern matching in that. Okay, and coming to this hetero associative, the same input is going to be matched and we are going to get the output. But the difference between here and here is the pattern matching will be happening based on the partial input that we are giving here, whereas here the pattern matching will be happening based on the pattern that it is making a matching with different sort of input. So this is what the main concept of auto associative and hetero associative. Auto associative is nothing but where we are going to get the pattern matching based on the partial input that we are giving into the system. When we are coming to the hetero associative, the same pattern matching will be happening here, but how the pattern matching will be happening is based on the different types of input that we are giving. Based on that, the pattern matching will be happening here. Y, where we are going to produce the output row vector by finding the weight of the matrix. Okay, now we are going to consider x as 1, 1, 1, 1, whereas y as minus 1, 1, 1, minus 1. So this is the input that we have taken here. The main formula that we are going to see for calculating the auto associative memory is, this is the formula that we are going to see over here, which is nothing but to calculate the weight, summation of p is equal to 1 to till p, s of t, p into s of p, which is this t represents nothing but the transfer matrix. Now let us consider we are going to take the first input x. By applying the formula, w is equal to summation of p is equal to 1 to p, s t of p, s of p. So considering this is as a s of p, we are just going to use this matrix as a transpose matrix, which is nothing but, so 1, 1, 1, 1 into 1, 1, 1, 1. Now we are just going to do a multiplication, that is a normal matrix multiplication. So what will be the answer for it? 1 into 1, 1, 1 into 1, 1, again 1, 1 into 1, 1. Next, coming to the next row, 1 into 1, 1, 1 into 1, 1, 1 into 1, 1, 1, and again for this one, 1, 1, 1, 1, 1, 1, 1, 1. Am I correct? So this is the matrix multiplication for the x that we have taken. Now we are going to do the same matrix multiplication for the next thing, that is y, that we have taken as a next input. So for the y, the same, this y is we are going to calculate with using the transpose. So how it will happen is minus 1, 1, 1, minus 1 into minus 1, 1, 1, minus 1. Now we are going to do a normal matrix multiplication. So 1 into minus 1 into minus 1, 1, minus 1 into 1, minus 1, minus 1 into 1, minus 1, minus 1 into minus 1, 1. Then 1 into minus 1, minus 1, 1 into 1, 1, 1, minus 1, minus 1, 1, 1, minus 1, 1, minus 1, minus 1, 1. Am I correct? So that we plus y. So what will be the answer? This and this. கொஞ்சம் கட் பண்ணுங்களேன். So now we are calculating the weight matrix for x and y. The answer is 2, 0, 0, 2, 0, 2, 2, 0, 0, 2, 2, 0, 2, 0, 0, 2. So this is the weight matrix for the whole input that we have given. How we are going to check whether it is correct or not? Here what the main procedure comes. So let me start here. So this is the overall output for the weight matrix that we have calculated for x and y. Now we are going to just check whether it is a correct or not. How we are going to check is, we have one logic called, if the answer is all comes in the positive way, which is nothing but greater than 0, the outer product rule that we are forming for this one is correct. If at all the value comes in the negative way, the outer product rule that we are forming for this one is not correct. This is the basic rule for calculating the auto-associative memory. Fine. So to calculate this, once again to check this, what we are going to do is, we are just going to multiply w with the x that we have already taken as an input. So x into w, which is nothing but, where we are going to just multiply this 1, 1, 1, 1 into 2, 0, 0, 2, 0, 2, 2, 0, 0, 2, 2, 0, 2, 0, 0, 2. Fine. So the answer will be 1 into 1 positive number, which is like greater than 0. So the answer that we got is, for the outer product rule, rule of auto-associative is correct. The same y also. So what happened here is, w is equal to y into w. So which is nothing but minus 1, 1, 1, minus 1 into 2, 0, 0, 2, 0, 2, 2, 0, 0, 2, 2, 0, 2, 0, 0, 2. So the final answer will be minus 2, 0, 0, minus 2, 0, minus 2, minus 2, 0, 0, minus 2, minus 2, 0, minus 2, 0, 0, minus 2. So here the answer, whichever it is coming, it is forming in the negative value, which is nothing but which is lesser than of 0. So the outer product rule for this one is auto-associative is not correct. So this is how we will be calculating the auto-associative network, how the network is formed and how the memory is managed using this particular formula. The same way we have a particular formation or a particular kind of calculation for the heteroassociative also. Now we'll see the next problem. Same sort of problem for the autoassociative. Now we are seeing the same sort of problem for the heteroassociative. But here is we are going to take everything in the form of tabular column. From tabular column we are going to take separate individual input and then we are going to sort it out. The same sort of formula is also mentioned here. But here we are going to see the formula in the way like this is for the input and this is for the target. S is indicated for the input that we are going to take and T is for the target input that we are going to take. These are the vectors. First vector, second vector, third vector and fourth vector. Now we are going to calculate the weight matrix for the each individual vectors. Now we will consider for the first one. S of P, which is for the vector 1. So W is equal to ST, which is nothing, stands for the transpose vector, transpose matrix. So S is nothing. So S is 1 0 1 0 and T is 1 0. So as per the formula, we are going to take this as a transpose matrix, which is nothing but 1 0 1 0 into 1 0. So the answer for this one is 1 into 1 1, 1 into 0 0, 0 into 1 1, sorry 0 into 1 0, 0 into 0 0, 1 into 1 1, 1 into 0 0, 0 into 1 0, 0 into 0 0. So this is for the first vector. The same way now we are going to calculate for the first vector is completed and now we are going to calculate for the second vector. So the same way the S is 1 0 0 1 and T is 1 0. So 1 0 0 1, as per the formula we are just making this transpose of matrix into a, this matrix into a transpose matrix. 1 0 0 1 into 1 0. So 1 into 1 1, 1 into 0 0, 0 into 1 0, 0 into 0 0, 0 into 1 0, 0 into 0 0, 1 into 1 1, 1 into 0 0. So this is for the second vector. The same way now we are going to calculate for the third one. So third vector has a S of 1 1 0 0, comma, target vector is 0 and 1. So as per the formula we are going to make this vector into a transpose vector. So S of T for the third vector, S of T is 1 1 0 0 into 0 1. So the answer will be 1 into 0 0, 1 into 1 1, 1 into 0 0, 1 into 1 1, 0 into 0 0, 0 into 1 0, 0 into 0 0, 0 into 0 0. So this is for the third vector. Now we are going to consider for the fourth vector. The same way for the fourth vector, the S is 0 0 1 1 and the target is 0 1 1. So for the fourth, the same way we are going to make this vector into a transpose vector. 0 0 1 1, which has been multiplied with the target vector 0 1 1. So the answer will be 0 into 0 0, 0 into 1 0, 0 into 0 0, 0 into 1 1, 1 into 0 0, 1 into 1 1, 1 into 0 0, 1 into 1 1. So we got the vector, which means we got the answer for the first vector, second vector, third vector and fourth vector. Now what we are going to do is we are just going to add all these vector to find out the weight matrix for the heteroassociative. Cut. So now we got the answer for the vector which I have written separately as S1, S2, S3, S4. Now to calculate the weight matrix, just we are going to add all these matrices. So to add the weight matrix, W is equal to summation of P is equal to 1 to till 4. Why 4 is we have took the vector matrix till 4 values. So S T of P into T of P. So here as per the vector P value is 1, 2, 3 and 4. So which will be like ST of 1 of T of 1 plus ST of 2 into T of 2 plus ST of 3 into T of 3 plus ST of 4 into T of 4. Now just we are going to add all these values. So 1, 0, 0, 0, 1, 0, 0, 0 plus, so this value belongs to the vector of 1. For the vector of 2, 1, 0, 0, 0, 0, 0, 1, 0. Then for this one, for the third vector, 0, 1, 0, 1, 0, 0, 0, 0 plus, as the same way now we are going to do for the fourth vector, that is 0, 0, 0, 0, 0, 1, 0, 1. Now we have took for the each separate vector, vector 1, vector 2, vector 3 and vector 4. Now we are just going to add all these vectors to calculate the weight matrix. So 1 plus 0 plus 0 is 2, 0 plus 0 plus 1 plus 0 is 1, 0 plus 0 plus 0 plus 0 which is 0, 0 plus 0, 1 plus 0, 1, 1 plus 0, 0 plus 0. So 1, 0 plus 0 plus 0 plus 1. So 1, 0 plus 1 plus 0 plus 0. 1, 0 plus 0, 0 plus 1. So answer is 1. So this is the weight matrix for the heteroassociative. In this class, we have seen how to calculate the autoassociative rule, which is the outer product rule for the both the autoassociative and the heteroassociative. In this class, we have seen the problem for how to solve the weight matrix for the autoassociative and the heteroassociative. So once again, we are going back into the overall concept. What is associative? As I said earlier, which is nothing but we are going to manipulate or we are going to work with the memory, which is nothing but we are going to save it and we are going to retrieve the information. How we are going to save and retrieve the information? Based on some pattern matching through it. So for this associative memory, we have two types of associative memory. One is autoassociative memory, another one is heteroassociative memory. So autoassociative memory is nothing but where we are going to get the pattern matching of memory, where those pattern will be of a partial sort of input or a noisy input. From based on that input only we are going to get the output. And when coming to the heteroassociative memory is the same sort of thing where we are going to save the data or we are going to save the information and we are going to retrieve the information. How we will be retrieving that information is based on the same thing called pattern matching. In this pattern matching, the input will be taken from the different parameters and we are going to match it. Fine. And the two differentiation between the autoassociative and the heteroassociative is autoassociative is a singly connected networks, whereas when you are coming to the heteroassociative is a double connected, which is a dual connection. The example for the autoassociative will be Hopfield. These are the These are the example for the auto-associative and the heteroassociative. Now coming to the Hopfield and the BAM. Hopfield is nothing but the same sort of pattern recognition where we will be giving the input to the particular memory processing, where the output will be calculated by matching the pattern. For identifying those things, we will be having something called activation functions. We will be having something called activation function, which is also based on the formula. This is also based on the formula, and for this also we have a derivatives, and the same way we are having the problem also to deal with this. Now when coming to the heterogeneous example is BAM. BAM is nothing but the bidirectional associative memory. As I said earlier, heterogeneous is a bi-connected thing. So the bidirectional associative memory is applicable only in the heterogeneous, and this Hopfield is applicable only in the auto-associative. So this is what the overall view for the associative memory. The main associative memory is of auto-associative and the heteroassociative. Apart from auto-associative and heteroassociative, we have furthermore classification based on this types. We have not only have Hopfield and the BAM, we have Hebbion rule. We have in Hebbion we have a binary Hebbion and multiple Hebbion also. So we have a n number of things to apply here, and we can able to get the data which we have saved in the memory pattern, where we can extract the data by matching the pattern. Thank you for watching this video. In this video we saw about the associative memory. In upcoming videos we will be seeing about the subtopics and the main program or a main problem, how to solve with all these things. And thanks for watching it, and we need the support.